In that instance, the data could tell us that there is a £100,000 solution to this problem that will basically wipe out the problem versus a £2 to £3 million investment that the hydraulic model had come up with at the treatment works, which didn't actually really fix the problem at all. The US is ahead on control, but the UK is ahead on operational proactive decision making and data and sensoring. At some point, each one will pull the other one up in the other area. So there will be more control in this AMP in the UK for sure. There are some good examples of that out there today. And I think if we're having this conversation in 5 to 10 years' time, I think you're talking a factor of 10, a factor of 20, maybe even a factor of 100 on the amount of control examples.
Brian, thank you so much for joining me today. I really appreciate it.
No problem. Delighted to be here.
So tell us a little bit about yourself.
Okay, so I'm a civil engineer. That is my background. And I guess from an industry perspective, I'm very much engaged with the data world now and bringing the benefits of AI, data, real-time processing into, I guess, the water industry and the water domain more widely.
Okay, so data, AI, where are we heading? What does the future of the water industry look like, say, 20, 50 years' time from now?
That's very interesting, a very open question, I think, in terms of where the general industry is going. There's definitely a trends around automation. I think obviously with a lot of the workforce, a lot of the knowledge in the industry, maybe potentially leaving the industry in the next 10 to 15 years, there is a big push towards automation with the various new technologies that are available to support that. And there's also, I think, more data available within networks and the ability to make more data-based decisions with the advent of AI, machine learning, the additional capabilities that exist now. I think the networks are going to look very different. If you look at the pipes that were put in the ground 100 years ago, they're not that dissimilar to what was used, say, 5-10 years ago. But I think particularly in the next 5 or 10 years, I think there's going to be a big change in terms of the amount of data, the amount of sensoring that goes into, particularly on the wastewater network side. And I think that is very much going to feed into sort of this operational data-led decision making from an operational point of view, but also from a controlling the network point of view. I think it's quite interesting to see where that will go in the future. I was actually at a conference last week and a utility presentation about operational AI-based operational control and decision making. And the utility officer that was speaking described the network of the future being like Minority Report, where everything is talking to everything. There's data coming from both sides from, okay, I've opened a valve, feeding that back. We're going to send a person out to make an intervention based on the data and the current situation in the networks. I think it's super exciting in terms of what's the potential that's out there over the next number of years, giving sort of the supporting technologies that are there now to push the boundaries forward in wastewater, particularly in my industry, but also, I guess, in water.
You can definitely imagine engineers of the future sort of having a big screen in front of them as moving things around. And I guess in a way, that's in the territory of what you guys do at Stormharvester, right? So maybe for those who haven't had a chance to learn about the work that you do at Stormharvester, would you mind maybe just giving a little bit of an introduction and maybe touch on how you're thinking about or approaching some of these challenges that you just spoke about?
Yeah. So at Stormharvester, we're really based around a data approach. We use AI and machine learning to allow utilities to make more informed and better proactive operational decisions. So that could be, for example, taking the data from a full utility network, combining that with some environmental data like hyperlocal rainfall, like groundwater levels, and giving the utility back a picture of what's happening in real time within their network. So say, okay, the level is slightly high in that pipe. That's representing that there's a blockage. However, tomorrow there's some rainfall, the level is high. That's not flagging up as a potential blockage because that's predicted based on rainfall. So taking in all the various different factors that affect affect the utility, and giving back that sort of proactive operational information that a utility can act on. So a utility can make a proactive decision to go and jet a sewer or investigate a pump or replace a pump based on the information we give them. We also use data, similar data sets, to provide more along the lines of sort of investment decision. So we're optimizing their investment decisions using that data as well. So it's like operational intelligence and also investment or asset intelligence. So that you're looking at the assets more long-term health, and you're advising based on the data, based on so how susceptible is that asset to 10 mil of rainfall, 15, 20 mil of rainfall? Is it more susceptible to long durations of rainfall, short durations of rainfall? Does its spill pattern match the groundwater level? So is it got a higher likelihood of spilling when there's high groundwater versus low groundwater and high rainfall in the summer? So dicing all that back in terms of the data and giving a utility a clear investment strategy based on what's actually happening at their assets today.
So I guess with that, there comes the implication that companies aren't already using real-time data. How is it typically done across the industry?
I guess we're now working with 9 of the 12 wastewater utilities in the UK. Those companies are making operational decisions based on data. They are sending jet crews, they are sending investigations or sensor replacement crews out based on what the data is saying, and they're largely proactive. I think in the broader industry, the UK is certainly leading on this one from our investigations internationally. Internationally, it seems to be a lot more reactive. They tend not to have as many sensors. And in addition to that, they make a lot of reactive decisions. So they'll only go and investigate a blockage if there has been a pollution event, if a level has triggered, so it's spilled outside the manhole or it's spilled at the CSO, they might go and investigate it. Where from an operational point of view, we're able to get them out much quicker. When we see the first signs of a level variation, you'll try and get your operations crew out there to jet that out to ensure that you don't have that sort of pollution event based on the data and getting them out there operationally. I think it's different in different places, but very reactive would have traditionally been the way. Before we got to the utilities, before we started working with them, everything tended to be reactive, where you would have a high level trigger, and during rainfall, you could have a lot of level triggers going off. You could have 20, 25, 30, 40% of your overall sensors could be in alert. It's impossible to react to that. So what the AI and the machine learning does is it distills that down to the important pieces of information the utility needs. What's actually an anomaly here? What is something that is not expected to happen based on the rainfall versus, okay, my pump is pumping a lot, but it's been very wet today. That's expected.
So I guess there are two different elements to it. There's the reactive element that you described, and you want to get reactive to become proactive through the use of sensors. But then I guess thinking about more asset investment decisions. So if companies aren't making asset investment decisions on real-time data, does that just simply leave them to make those decisions based on what modeling?
Yeah. So you've got two different ways of doing it. You can do it based on the data and what you're seeing at what the assets are actually suffering, or you can do it based on a hydraulic model maybe, or some form of deterministic model. Sometimes these models can be calibrated back to the data, but it tends to be a difficult process to really calibrate models back to data, and you're generally using short periods of data to do that. In some cases, you can certainly look at the data from within the networks and use that along with the AI and machine learning to help you inform your decision making around your asset investments, or at least to validate the hydraulic model. What we're finding is that because the hydraulic model in a lot of cases is a theoretical perfect situation of how the network should work, it's not always the case in reality. For these pipes have been underground in some cases for 100, 150 years. They have evolved, there's different flows coming in. So yeah, there's a lot of investment decision making, and obviously with the utilities investing more than they've ever done before in this AMP, we are trying to make sure that money is spent in the right way to get the best benefit, to give them the best chance of reducing their spill numbers as much as possible. And by using a hydraulic model to make all of those decisions, I don't think they're going to get best bang for buck in terms of maximizing that investment into the network. Now, I'm a hydraulic modeler, or a recovering hydraulic modeler, as I like to say, but there is always a place for hydraulic modeling.
You mentioned overflows, CSOs. Obviously, so CSOs is one of the hot topics in the press at the minute. A lot of criticism on the industry there. How does this thinking tackle that mega challenge that we have as an industry?
Yeah. So I think the governments now are setting out, and the money is becoming available from Ofwat to invest to really make a difference and really cut down on the spills. Particularly the amounts of money that have been set out in the next AMP are, like I said, more than what's ever been set out before, and quite staggering in some cases. It's really important now that money gets used in the best way and most efficient way possible to minimize the maximum number of spills. So we want to take as many spills out of the networks as possible with that money. So the investments that we make into the network are going to have to be really targeted to ensure that every pound that's spent is going to have an effect on spills. And what we've seen in the past with the hydraulic models, and where it's based on a sort of a simulation, is that you can come up with a solution. So a solution would be, okay, a bigger pipe or a storm tank or something like that, that doesn't fit the spill pattern, that doesn't fit what's actually happening on the site. So the solution you might come up with from the hydraulic model could be to eliminate some of the above ground runoff into the network. However, when you look at the data, the spill pattern and the data is showing us that this site is spilling because it's got underground infiltration, or it's got a river, or it's got an inflow point, a connection back into the network. You're going to invest your money in different ways based on the data and the hydraulic model. And in most cases, it is very hard to argue with the data, because that is what is happening. That is a representation on what is happening at that site. Whereas the hydraulic model is a simulation of, this is a deterministic model of what would be happening if everything was working as set out and perfectly designed, with no influence from various different inflow points and environmental factors and things like that. So I think it's super important, if we're going to really get our handle on this and really get our head around what's happening, we're going to have to use the data to guide us to make the most efficient investment decisions. Because I have seen scenarios where there was a plan in certain catchments to, say, upgrade a treatment works, £2 or £3 million in one catchment that I'm familiar with. We did our assessment of the catchment, so we ran that through the AI, and the model told us there is an inflow coming in at one point in the network. We tracked that back to the point, and it was where a water course, where the sewer went under a water course. And what we could see in that instance was, okay, you're going to increase your treatment works by £2 or £3 million. But what you're doing is basically taking the full capacity of that pipe from a river. So you're transferring it from a river to a pumping station. You're having the pleasure of pumping it twice, getting it into your treatment works. And for 2 or 3 months a year, you're spilling that out because the treatment works wasn't designed to take a full flow from a river, obviously. In that instance, the data could tell us that there is a £100,000 solution to this problem that will basically wipe out the problem, versus a £2 to £3 million investment that a hydraulic model had come up with at the treatment works, which didn't actually really fix the problem at all. It gave you more capacity, but you were still pumping the river twice and then trying to treat mostly river flow at the treatment works. And not even getting to the end of the river flow. It was still going to cause spills, but it was the best that they could do with the flows. So it's really making those better investment decisions, so you can really, put out the fire where it is actually happening, not trying to put it out somewhere else.
And I was going to ask about that, because I guess ultimately, or theoretically, by making more informed decisions during your capital investment program, could you potentially eliminate the need for some new infrastructure by
Yeah.
actually just optimizing your existing infrastructure?
Yeah, absolutely. It is in certain catchments, in certain situations, there you will have the ability to optimize what you have instead of putting in a completely new, say, storage tank, storm tank, or whatever it is in the catchment. Now, I think that only that exists in certain scenarios where the catchment, maybe there's some big pipes that are underutilized in part of the catchment, and you've got spilling happening somewhere else in the catchment. In that instance, maybe you can hold back some flow. You can allow a pumping station maybe fill up during rainfall. You can ensure that different pumping stations talk to each other to try and hold back and minimize and reduce flow. So I think there is definitely room to travel in the industry around that control piece and using automated control to reduce spillages. I think it's quite interesting. How I would see this is the US is ahead on control, but the UK is ahead on operational proactive decision making and data and sensoring. At some point, I see the two things maybe each one will pull the other one up in the other area. So there will be more control in this AMP in the UK for sure. There are some good examples of that out there today. And I think if we're having this conversation in 5 to 10 years' time, I think you're talking a factor of 10, a factor of 20, maybe even a factor of 100 on the amount of control examples, really good control examples that will exist in wastewater networks in the UK. Similarly to that, if you look at the US, they've got a lot of really good control examples, but not so much on the sort of dense level of censoring and operational decision making. And some of that is down to regulation, but it still does, there still is a business case and a value proposition. So I think what will happen over the next 5 to 10 years is there will be a balance out between those two things. I think the US will maybe increase their sensor density, increase their proactive maintenance, maybe not quite to the UK level, but then the UK will increase their automated control, maybe not quite to the US level. I think that's how I would see it play out over the next couple of years.
The sort of UK versus US comparison is also quite a fascinating one because the markets are so different. UK, a lot more concentrated over 12 of them, as you said. And then the US, a lot more diverse, a lot smaller, a lot more separated and independent. I guess if the industry is heading towards that way of real time decision making, performance based maintenance, do we still need to go through a bit of an evolution or a bit of a sort of transformation to be able to actually embed this sort of real time decision making type thinking into our day to day operations? Or do you think that we've already overcome that hurdle within the UK, having with SCADA devices been around for quite a while now?
Yeah, I think there's different steps on that journey. So I think, there's always this thing about we're not concerned about giving it over to the machine. What if the machine turns against us? But I think in reality, I've seen a lot of good stuff in the US. We've spent some time with Luis Montague, and he was the chap that invented a lot of the core technology that sits behind Xylem's MNet product. And he walked me through it, and it becomes very palatable when you see, okay, we can have a first level here where it's not fully controlled, where there's like decision support. You've got 10 options, and the machine tells you, we recommend you using option one, which is drain down these catchments and go into this kind of mode. Okay, you've got option two, which tells you do something else, use it in a different way. So you don't have to go straight to the full automated control and full takeover. I think there are steps on that journey. And I think it is quite interesting to see utilities will start to adapt at very early stages. And in some instances, maybe it's just changing control philosophies or having multiple control philosophies based on some parameters or some algorithms that are being run, right through to, okay, everything is completely automated and your whole network is basically talking to itself. And there are great examples of those happening in the US. There's a number of examples of them happening in the UK. And I think you're always going to have that balance and that challenge about moving over to a more automated control system.
Are there any changes to required from a regulation perspective? Are we, as a water industry, allowed to actually almost sort of trust the machine, trust the computer for operational decisions?
Yeah, that's a really good question. There are, I know of, in a number of utilities, ongoing regulator discussions around permits. A lot of the permitting system, as this technology evolves, will be seen to be old fashioned. I think that it's very static in terms of when you can spill, when you can't spill. And I know there's a number of utilities having conversations about, okay, if we put in a control system, it means we're going to spill more in one location, but it means we're going to spill less in two other locations that actually are more sensitive. Maybe they have a higher environmental significance, and you can push your spills to other places. You can take more control of parts of your network in those scenarios. So I think yes is the answer. In short, there will be regulator changes required. I think some of those conversations are ongoing today. I think it's really around permits, and spill permits are going to have to be looked at. And I think there's going to have to be more dynamic, more flexible in terms of how that permitting is done going forward.
Thinking about like the US example, and the US, as you've described, being a lot further advanced in terms of that sort of automated control of the network. Are there any sort of key learnings maybe the UK's Ofwat need to take from the US to be able to really allow the success of automated control?
Oh, that's a really good question. I think it's important to have good data feeding back in to
Mm.
inform any control system. And I think these automated control systems, personally, I think they are suited to certain catchments and not others. There are certain catchments where you do not have extra capacity, where there isn't a part of a catchment upstream that is under capacity during critical periods, during critical rainfall periods. Just everything is maxed out, and then you need, okay, why is that? Is that groundwater? Is that something that's coming in from above? Is it too much hard standing area? Is it first flush from a quick rainfall event, from a short intense rainfall event? So there is only certain catchments where this will work. So it's not a blanket solution to that automated control is going to work everywhere. I don't think we quite know yet what percentage of all catchments, but my suspicion is that it's quite small. It's not you're not looking at anything like 50%. You're looking at real small numbers in terms of where this will be really beneficial, where the value proposition can be added up to do that. And I think that's probably one of the key learnings to take from the US, is that this isn't a solution that's going to do absolutely everything every time, but in certain catchments, it will be the most economic way to reduce your spills in certain catchments in certain places. And I think understanding its limitations is as important as understanding the benefits and what it can achieve for you.
Why is the US more suitable for catchment wide automatic control? Is
Yeah,
it
no,
larger
I was
geographic areas or?
Yeah, I don't think it actually is. I think there's more utilities, there's more area, so there's more examples of it out there. But percentage wise, I think they're ahead of, obviously, because the UK is a very small number of examples, but I think the US is ahead of that. But it's not mass market. It is niche in terms of the catchments that it's in and where it's suited. Is the US, and I suspect this, but I don't know this for sure. I think the US, their makeup of their networks are more likely to have a big interceptor pipe somewhere in the network, just because a lot of them are built more recently, and they've tended to build them with big collection systems, big interceptors that collect a lot of smaller parts of the network. So where you have that, you've generally got a lot of spare capacity upstream because they tend to be quite big pipes. So it's just the makeup of the network can suit it more sometimes in the US. But like I said, I've definitely seen examples in the UK where the analysis has been done on it, and in those catchments, this solution stacks up ahead of, say, a capital upgrade of the treatment works or a big storm tank. That putting that automated control actually does help that.
Brian, one last question to finish, if I may. I'm fascinated by your journey over the last few years, and the fact that as of today, working with 9 out of the 12 wastewater utility companies here in the UK. I mean, that scale of being embedded in a market is really quite impressive. And the technology implementation in the water industries, it can be quite tricky at times. What have been your sort of key learnings over your journey, and what sort of advice would you give to maybe other innovators or startup founders trying to move into the utility space?
Yeah, it is, as you say, it is a slow, traditionally has been a slow industry. We've bucked that trend, I think, a little bit. And I think we've done it for certainly two main reasons. I think the technology it works. It's good, it adds benefits. And when people start using it, they don't want to stop. I think that is a critical thing from a utility perspective. And the second thing, which is always important, is that it saves the utility money. You've got better investment decisions. You can save significant amounts of money in an operational sense, but also in an investment sense. I think they're the two. They're the really the two of the main reasons why we have been so successful over the last number of years. It has been, I think, certainly the last 2.5 years have been absolutely unprecedented in terms of the speed that we have been able to scale. We've gone from maybe 3 years ago, we probably had 15 people. Now we have over 40, or almost or around 40 anyway. That's a remarkable growth, particularly for somebody that is a company that is addressing the wastewater sector, if you like, a notoriously slow sector. Even within the water industry, wastewater has been always been the slow companion to keep up. And in terms of advice for a sort of a founder in the moving into the water industry, I think it's probably resilience is so important when you're starting a business. You will get knocked back. You will get kicked along the journey. It won't always turn out the way you wanted it to. You will have days when you think, my God, I'm just banging my head off this wall. It is not opening for me. And I think the most important thing to have is that resilience. Obviously, you've got to understand the industry. You've got to be credible. You've got to be able to work your way through problems as you go through the industry and understand that product market fit and try and get something that solves a significant problem for a utility. But I think it is that you stay resilient through the journey. You're constantly getting to the end of one section and thinking, okay, there's clear road ahead. No, I'm knocked back a little bit there. So you've got to have that resilience. That is any of young founders, young tech entrepreneurs, any of the mentorship programs or the school courses that I speak at, that is the number one message when I'm speaking to people, is that it's that you gotta have that determination and that resilience and that thing inside you that says, I'm not going to give this up. I'm going to keep going. I know I'm right. We're going to get through this.
Absolutely. I completely agree. And I think you always have to have resilience so you can then have the opportunity to build resilience in the water industry. So it's a full circle.
I like that.
Brian, thank you so much for your time. I really appreciate it. It's been absolutely fascinating. I'm so excited to really see this move the needle in the industry we all know and love. Thank you for your time.
No worries. Absolute pleasure. Thank you.